Right now, at this very moment, somewhere in our galaxy, a star is being torn apart, shredded, stretched, and swallowed whole by something so powerful, so dark, so unimaginably violent that not even light itself can escape it. Scientists have stared at it for decades. Mathematicians have tried to calculate it. And yet, what happens inside a black hole remains one of the greatest unsolved mysteries in all of human history. But today, we're going in. Stay with me until the end, because what you're about to discover will completely change how you see the universe. Before we jump in, literally, let's make sure we understand what we're actually dealing with, because most people get this wrong. A black hole is not a hole. It's not empty space. It's not some kind of cosmic vacuum cleaner floating in the sky. A black hole is an object, an incredibly massive, incredibly dense object where so much matter has been crushed into such a tiny space that gravity becomes almost infinitely strong. Think about it this way. Right now, Earth has gravity. That gravity keeps you on the ground, keeps the oceans from flying off into space, keeps the moon in orbit. Now imagine taking all of Earth, every mountain, every ocean, every city, every living creature, and crushing it down to the size of a marble. Same mass, same weight, just incomprehensibly compressed. The gravity from that marble would be so intense, it would rip you apart before you even got close to it. Now scale that up. Not Earth, but a star. A star 20, 30, even 50 times bigger than our sun. When a star that massive runs out of fuel, it doesn't just dim and fade away. No, it goes out with the most violent explosion in the known universe. A supernova. For a brief moment, a single dying star shines brighter than an entire galaxy containing hundreds of billions of stars. And when that explosion is finally over, if the remaining core is heavy enough, gravity wins. Completely, totally, absolutely. The core collapses in on itself. In less than a single second, something the size of a city becomes an object smaller than an atom. And just like that, a black hole is born. The gravity is now so strong that nothing, not gas, not dust, not particles, not light, can escape. That boundary, the invisible line that marks the point of no return, is called the event horizon. Cross it, and you are gone, forever. Now, here's where it gets truly mind-blowing, because black holes don't come in one size. They come in sizes so different from each other that the comparison is almost impossible to put into words. The smallest type, called stellar black holes, are formed from dying stars like the one we just described. They're typically about 10 to 24 times the mass of our sun. But here's the thing. In terms of actual physical size, they're only about 10 to 20 miles across. That's smaller than most cities, smaller than the distance you drive to work. Yet the gravity is so extreme, if you replaced our sun with one of these stellar black holes right now, Earth would just orbit it, like nothing changed, just colder, darker, but still orbiting. Because a black hole doesn't suck things in like a vacuum, it just has gravity like any other massive object. It's only when you get too close that things get dangerous. Then, above stellar black holes, there are intermediate black holes, hundreds to thousands of times the mass of our sun, still mysterious, still not fully understood. And then, at the very top of the scale, the absolute monarchs of the universe, supermassive black holes. These aren't just big, these are incomprehensibly massive. The supermassive black hole sitting at the center of our own Milky Way galaxy, a monster called Sagittarius A star, has a mass 4 million times greater than our sun. 4 million times. Let that number sit in your mind for a moment. But even that isn't close to the biggest. In 2019, scientists accomplished something that had never been done before in human history. Using a network of radio telescopes spread across the entire planet, working together as one single Earth-sized telescope, they captured the very first direct image of a black hole. It was the black hole at the center of a galaxy called M87, and its mass, 6.5 billion times the mass of our Sun. Its event horizon, the point of no return, is so large that our entire solar system, every planet, every moon, every comet, every asteroid, would fit inside it, with room to spare. And here's what makes this truly unsettling. There are hundreds of billions of galaxies in the observable universe, each one with its own supermassive black hole at the center. The universe is absolutely filled with these monsters, and we live in a galaxy orbiting one of them. All right, now comes the part you've been waiting for. Let's actually go there. Let's say, hypothetically, you're an astronaut, brave, curious, scientifically adventurous, and maybe just a little bit reckless, and you decide you want to fall into a black hole. For this journey, we're going to use a supermassive one, like the beast in M87. Here's why, and pay attention because this matters. If you tried to fall into a smaller, stellar black hole, the tidal forces, the difference in gravity across your body, would be so extreme that they would rip you apart before you even crossed the event horizon. You'd never make it inside. But with a supermassive one, the event horizon is so enormous that the tidal forces there are actually relatively gentle. You'd cross it without feeling anything dramatic at all. So, supermassive it is. You're in your spacecraft, the black hole is ahead of you, and from a distance, it looks almost amazing. Surrounding the darkness at the center, you can see a brilliant, blazing ring called the accretion disk. This is material, gas, dust, the destroyed remnants of stars, all orbiting the black hole at nearly the speed of light, heated to millions of degrees, radiating more energy than entire galaxies. Light from the far side of the accretion disk is being bent around the black hole by its gravity, creating a halo of light above and below. It's the most dramatic, most violent, most beautiful thing you have ever seen. And at the center, a perfect sphere of absolute darkness, the black hole itself, where no light returns. You begin drifting closer. At first, nothing feels different. Gravity pulls you gently, just like any other object. But then, something strange begins to happen. You look back at your colleague watching you from a safe distance in another spacecraft, and you notice they're moving in slow motion. Their gestures are sluggish. Their signals take longer to arrive. This isn't a malfunction. This isn't your imagination. This is time dilation, one of the mind-bending, reality-defying predictions of Einstein's general theory of relativity, and it is completely 100% real. Here's what's actually happening. Gravity doesn't just pull physical objects. Gravity bends space-time itself. It warps the very fabric of the universe. And time is part of that fabric. The stronger the gravitational field, the slower time flows. You are now deeper in the black hole's gravitational field than your friend is, so time is passing more slowly for you than it is for them. From their perspective, as you fall toward the event horizon, your movements slow, your signals redshift, stretching to longer and longer wavelengths. Your image dims, until finally, right at the event horizon, from their point of view, you appear to simply stop, frozen, suspended at the boundary for eternity. A ghost image, growing dimmer and redder, until it fades away completely. To your friend, you never crossed the event horizon. You just hung there forever. But what about you? From your own perspective, crossing the event horizon feels like nothing. No wall, no force field, no alarm, no dramatic moment. You cross an invisible line in space, and nothing feels different at all. Except, you can never go back. The moment you cross the event horizon, even if you immediately spin your spacecraft around and fire your engines at maximum thrust, you cannot escape. because inside the event horizon, the geometry of space-time has changed completely. Every direction, forward, backward, left, right, up, down, every single direction you can possibly travel leads to the center. There is no away anymore. Moving forward through time is the same as moving toward the singularity. You cannot stop it, any more than you can stop time itself. You are going in. Now, this is where things get truly horrifying. As you fall deeper into the black hole, something begins to happen to your body. You begin to stretch. Not metaphorically, not slightly. You begin to stretch in a very real, very physical, very final way. Here's the physics of it. Gravity from the black hole doesn't pull your entire body equally. The side of your body closest to the